I do want to talk about just briefly what the midterm exam will look like, okay, for this class next week. Okay, so the midterm exam will be on pen and paper. Okay, I'd like to have you use Excel, but it's difficult to grade for a midterm, right? So we'll just do it on pen and paper. It'll be quick. We'll take probably the first hour of class to do it is all, so it'll be time limited. And essentially I'm going to ask you questions, probably one like this, so a linear optimization question. I'll give you a word problem like you see on the screen and ask you to solve it, right? So you'll have to basically sit down with pen and paper and write down the equations for the constraints and the objective, and you'll have to solve for where the constraints meet up, figure out the value of the objective, which one is the best, right? Maximum, minimum, whatever it is. Okay? So probably one question like that. I will ask you some questions on data mining, although I can't ask you to do any data mining, obviously, on pen and paper. So the kind of question I would ask you would be something like, here are two lift charts from two different data mining algorithms. Which one is the better algorithm, just judging by the lift charts alone, and why? And you would look at that and say, which lift chart is better in terms of a bigger distance between the algorithm and the average guess, the average random guesser. Okay, and whichever one's better than the average, more so than the other, right, is the better algorithm. Easy enough. I might also ask you questions like, here are some data values, say for, like we did tonight, the origin for the cars. So origin 1, 2, and 3. How would you convert that from a categorical field to numeric field? Okay, and you would tell me you would have to use dummy variables and give me an example. So you'd have an origin 1 field, an origin 2 field, and an origin 3 field. And every record would have a 0 and a 1 in each of those fields. They would have exactly 1 1 and 2 zeros across those three fields. Okay, so I might ask you a question about how you transform between one data type and another. Okay, that's important. I will almost certainly ask you some kind of question about why we use partitioning. Okay, so we use partitioning to enable us to detect overfitting. So we know when the algorithm is trying so hard to fit patterns that it's finding patterns in the noise and the randomness of data, not in the real data patterns themselves. Okay, and we do that with partitioning, where we use part of the data to build the algorithm, find models or find patterns in, and we use another subset of the data, the validation data, to test the algorithm on and say, once for some number of iterations of building this algorithm, we'll get better and better at predicting or classifying the validation data. But at some point, the algorithm starts finding noise in the training data or patterns in the noise that makes it do worse and worse in the validation data that doesn't have that particular noise in it. Okay? So when we know that the algorithm is doing better in the training data but worse in the validation data, it means we're overfitting. It means we're finding a pattern that doesn't really exist in the validation data at all. So we know we can stop. So I'll ask some kind of question with that. Okay, I won't ask you to do anything mathematical. I'll just ask you conceptually, what is overfitting? Why do we partition? How does partitioning help us avoid overfitting? As long as you understood what I just said, you could repeat it back in some form. That's what I'll be asking about. The only other thing about data mining that I might ask is, of the three algorithms we studied, okay, k-nearest neighbors, classification and regression trees, and multiple linear regression, I might ask questions about their limitations. So which of those algorithms can be used for classification? Which of them could be used for prediction specifically? Or I might ask, which of those algorithms cannot work with categorical data? Which of them maybe not work with numeric data, or so forth. Okay, so the limitations on how they can be used or what they can be used to do. So we talked about that. So k-nearest neighbors can do both classification and prediction, but it can only, so it can predict numeric and categorical results, but it can only do that with fields that are numeric, because it has to know a difference, right? It has to take one record value minus another record value. You can't do that with categorical data. Every difference is a difference. There's not meaning to it, so it needs numeric data to do that. Classification and regression trees can use both kinds of data. They can split data into two subsets using a categorical variable where it says these categories go one branch of the tree, other categories go the other branch of the tree. They can split on numeric data by saying values less than or equal to some point go with one branch, values greater than that point go to the other branch. Okay. Multiple linear regression can only work with numeric data. Okay. So theoretically, we did not discuss an algorithm that can only work with categorical data. Okay. Just so you can remember, they exist. There are algorithms like that, but we did not talk about one. So I would not ask about that. Okay. So that's what I would ask about data mining. Further back than that, there will be some kind of problem on forecasting, short-term forecasting. So short-term forecasting, you remember, we talked about four different models, I hesitate to call them algorithms, but they are algorithms of a kind. Moving average, where you just average the last n values to predict the next one. Smoothing, or exponential smoothing, which basically balances between the last observed value and the cumulative result of all previous values represented in the previous forecast, okay, to make a forecast of a future value. And then we did exponential smoothing with a trend, where you both try to forecast based on the values themselves, and you try to predict a trend, upward or downward, based on the differences between previous forecasts. Okay? And then we added not just trends, but also cycles, where you actually figure out, is there a cycle in the data that repeats every p observations, every p time units, that we can use to sort of either increase or decrease the forecast based on that cycle. Okay? So I might ask conceptual questions like the alpha parameter of exponential smoothing. What's the intuitive or the conceptual meaning of a large alpha value versus a small alpha value? Okay, so a large alpha says we care more about the recent observation than the historical observations. A lower alpha value means we care more about the historical observations cumulatively than the most recent one. Okay? So that's the trade-off of an alpha. And I might ask similar questions about beta or gamma for the exponential smoothing with trend and cycles, kind of the intuitive or conceptual meaning of a high versus a low value in those. Okay. I might have you do a little bit of math at doing some forecasting. Okay. I wouldn't have you forecast 10 time units or anything like that. If anything, and I wouldn't have you do math that is prohibitively difficult. Okay, so I'm not going to give you some crazy alpha value of 0.384 and forecast or observed values that are decimals and everything like that. It'll be simple whole numbers, simple numbers that you could probably do in your head. Okay, if you want to bring a calculator, you're certainly welcome to use it. It's never my intent to grade you on your math skills. Okay, I assume by now you've been graded on math skills in some math course. Okay, you don't need to be graded on doing math in this class. You need to be graded on understanding the models and the algorithms. Okay, to do that, sometimes you have to show me how they work, but I'll make the numbers come out as easy as possible. Okay, so that you don't trip up on the numbers. And I think that's it. So forecasting, data mining, linear optimizations, at least simple linear optimizations of two variables by hand, will be what's covered on the midterm. So next week, be sure and be here a little early if possible. The midterm will start promptly at 6 p.m. And will end most likely at 7 p.m. Okay, I haven't written it yet, but I'll gauge the time it takes after I've written it, and there will be a time limit. Okay, so next week 6 p.m. to something like 7 will be the midterm. Following that, or a short break after that, we'll start talking about more linear optimizations in Excel, nonlinear optimizations, and so forth. So more optimization models. Okay. Any questions about the midterm? Anything I didn't answer about what it'll be like? For future reference, the final exam will be similar to the midterm. It'll just cover more material. So it'll be longer. It'll cover more things that we've talked about subsequent to the midterm, but it'll look very similar to it. So I suspect the midterm will be something like just a page or two of some questions, maybe somewhere between 5 and 10 questions. A couple conceptual, maybe a few that involve a little bit of math, but that's about it. Okay. Thank you all very much. The good news is we're going to end early tonight, so I will see you all next week. And for those on the recording, hopefully you've learned something.